This is Algebra 1, Term 4, Lesson 5, Finding Zeros. We'll start with the Desmos activity, and then we'll come back to slides to work on finding zeros that are not in quadratic functions, but in other types of functions. And then we'll work on some vertical motion problems. Let's get started with Desmos. So our Desmos activity today is going to help students relate the factors of a quadratic equation or quadratic function and the zeros of the function. And so we have a total of 11 slides. The time it takes you to do this will vary depending on your kids, but I would say most kids are going to go through this one pretty quickly. And we'll start with our first screen here. Now on this one, they will slide these points over the graph until they place them on the zeros. A zero is an input that produces an output of 0. So I'm not telling them where those are. I'm not giving them up front what that looks like on a graph. I'm having them discover it themselves. Now as soon as they do put both of those points in the correct spot, the word correct will appear on the screen. So they will get immediate feedback. And know that they found them. And then also, what do we call the points that represent the zeros? Would that be the x-intercepts, the y-intercepts, or the vertex? And so in this point, we're just getting started. I'm thinking most kids are going to know this, but you never know. So take your time and make sure they know this. We want to go as slowly as we need to go to get every one of the students on the same page. Now this one we have 4 possibilities, and these are all written in factored form. Now I have given them the graphing calculator, so they could technically just type each one in until they find the one that matches, and at this point I'm not opposed to that. But we do want to see if they can make the connection between the zeros and the factors, and when they type in or they choose an answer, it's going to give them immediate feedback. It will say no, yes, excellent, and why. So they will get feedback on all of these. This is supposed to be an inquiry task, so hopefully you're not talking too much. You're letting them figure these things out for themselves. All right, now this next one, they are given a function in the blank, and they are to adjust this equation to fit this graph. Now, they are going to guess and check, and that's good. We want them to guess and check. You don't want them to go immediately to the right answer, because that guessing and checking is what helps them actually remember what this is doing. Now, if they were to go ahead and check their answer now, which actually is not a bad idea, it will show the parabola, and you can see now that that does not have the correct x-intercepts. It should be crossing the 2 blue points, and so they will click on Edit My Response, and then they will begin to change it. So tell them to guess and check. All right, and then they'll do it again. Same thing, same numbers. So if they click check, it's way over here. We want it to go through these points. So let's have them guess and check until they can make that parabola intersect those 2 points. And here we have 4 equations. Which one would fit this graph? Now on these, they are able to click on the graph to see what the coordinates of the x-intercepts are, and also the vertex and the y-intercept. Not that they need the vertex this time, but tell them to click on the graph to show the coordinates if they need them, and then to choose the equation that best fits. It will give them feedback. All right, now we're getting into the formality. So if I were you, I would probably pace kids to not go past screen 5 until most of the kids are comfortable and have already kind of made those connections, and now we're going into a formal definition. The factored form for a function looks like this: x equals x minus r1 times x minus r2, where r1 and r2 are the zeros. So that's why these have the parentheses. You might note the minus sign in the form is kind of giving them a reason for the signs of these zeros and the signs they're seeing in their factors being opposites. So this would be a good conversation to have here. I have several teacher notes in your teacher moves, so be sure to check those. This one has sample responses. So here we have another function, f of x equals x times x plus 1. What would be the zeros for this function? Now they do have their graphing calculator, so many of them will click and use the graph to figure that out. But before they move on, let's talk. If you weren't looking at the graph and you were just looking at this equation, how could you look at this equation and determine the zeros from just looking at this equation? On the next screen, we're doing this again. The R1 and the R2 are the zeros for the function, so they're typing their own with that knowledge now. They shouldn't really do anything differently. And then here, again, multiple choice. They will get feedback. So they're practicing over and over, but in a little slightly different formats. And then one more. So on this screen, we're introducing a negative coefficient. Does that affect the zeros? Good time to have the conversation about the negative. What is it doing to this function? And the last thing they'll do is match up the zeros to the equations and then the graphs. So they should be able to match all those together. There are 4 sets of 3 cards. We'll head back now to our slides. Now, as we're back in our slides, we're going to do some finding zeros using other types of functions. So here's a good review of our parent functions. What type of function is this? What is the zero for this function? And explain how you know. Here's another one. What type of function is this? Where are the zeros? Tell me how you know they're zeros. And classify this function. What is the zero? Explain how you know. Now once they've done that, they're going to do this without graphing. And I would encourage you to ask them not to graph at this point. See if you can figure this out without looking at a graph for this function. What is this function called? What is the zero of this function? And how can you use this equation to determine the zero? Same here, without graphing, without looking at the graph, can you determine the zeros? And how would you do that? And then finally, this one's a little tricky, but what would be the zero for this function? And by the way, how do we know there's only one zero for this function without even looking at a graph? How could you know that? If there was only one zero, how would you know? All right, here they are given zeros, and they have 5 different functions here, and they're going to drag the function into the table to correspond to the zeros that are listed. So have them match those up. This would be a great way to do a quick check of your kids, just to come around. If I were grading this assignment, this is typically the screen I would look to, because they've already done their Desmos, and I can see in there from the dashboard a lot. But this would be a real quick check for me as a teacher to see if they know their zeros and how those relate to these equations. Will they be graphing these? Well, actually, I would encourage them to try it without graphing them and then maybe use graphs to check. That would be my recommendation. And then finally, we're going to go back to our vertical motion model. And so in this case, we are going back to GeoGebra. It's the same app we used earlier. They're going to adjust the h sub 0, which is the initial height, and make that 80. And they're going to adjust the initial velocity, which is v sub 0, and they'll make that 64. And then they will slide the t to the positive 0. Now, that doesn't mean t is 0. It means it's a 0 of the function. So you may need to talk a little about that. If you're seeing kids put t is equal to 0, that is not the 0 in the function in this case. So they will need to move it. And then I'm going to ask them about the other 0. Well, there's only one positive 0, and there will be a negative 0. And so they will need to tell me what that is. They should be able to see it on their screen, but if they're not able, tell them to adjust their scale, and they can move the scale of the graph in and out so that they can see the negative values. And then what did these zeros reveal? Now there are 2 zeros, one positive and one negative. So the positive 0 has some meaning in this context. It has something to do with the height of the object that was thrown upward. I have given them some notes in their slides, so let's take a look at those. Okay, down at the bottom here it says, remember that h represents the height in feet and the t represents the time in seconds since an object was thrown upward. So these zeros have something to do with the height of the object. But one of the zeros doesn't really fit this context, and you want to see if they'll come up with that without you saying it. So give them a chance to tell you what the two zeros are, and then talk about what both reveal in context. Only one really fits the context, the other does not, and have them explain why. Now the last part is new, and this is based on their assignment they just did in their Desmos activity. They will need to replace those question marks with numbers, and then they will need for it to represent the exact same graph. Now that's not on the app. They can't type that in. If they want to make sure it's the same, they could type the equation that was given on the app in GeoGebra and type the equation written in this form, both of them in the Desmos calculator, and it will correspond. Hopefully they don't need to do that because they've just found their zeros, and their zeros reveal those factors, so they should be able to figure out what goes there. So again, this time I'm not telling them what to put in the app. I'm simply telling them that an object was dropped from an initial height of 144 feet. So they need to decide where those go in the GeoGebra app, and they may decide not to even use the app. They may decide to go straight to the Desmos calculator because they already know what to put in there for those question marks. So that's kind of up to them if they want to go straight to Desmos or if they want to play in the app first. I'm fine either way. And then they're going to graph the function that they're given, that they've created by putting in their initial velocity and their initial height, and they're going to graph the function. They'll locate the zeros of their function, and then they're going to write this equation in factored form. Now here's the thing. It's really tough to see both zeros in the app. So if they're trying to see it in there, they're probably going to be fighting with their scale and having a little bit of a difficulty getting that visible on their screen. So I do encourage them at this point to go ahead and get into their Desmos calculator and begin to graph the initial function, and then they'll graph this one right alongside it on the on the second row of the calculator, and they want to make sure these two match. And then again, what do these zeros in this function reveal in this context? Now here's something I also say, and I use something a little bit funny when I do it to help my kids not forget. But I ask them to adjust their scale in their window in Desmos so that you can see the vertex and the zeros and that the parabola fills the grid. So what they'll do when these y values are really high is they will just zoom out, and you'll get this super skinny parabola. Sometimes it even looks like a vertical line segment. It's so skinny. And so I say no skinny parabolas. I say that out loud multiple times, and so they'll start saying it, no skinny parabolas. And that's what I want to hear. I want them to adjust that window to make that graph look nice, to look like a parabola. And I don't want those x-intercepts to be, right next to the y-axis. They need to be kind of out. So adjust the scale, adjust the window, make it fit, make it nice. I will give you examples of what this looks like, so you can help your students that are struggling to get their parabolas to look nice. You can help them with those things. And this concludes our Finding Zeros assignment. Next time, we'll be taking our first test in Term 4. Y'all have a great day.